answering advanced spatial analytic questions. My name is Ian Erickson. I am a principal engineer with Tableau. I've been with Tableau for about 4 years or so. This is pretty mature, right? This, the content in here is advanced, right? We're not going to spend a lot of time in Tableau. And the reason why is because Tableau can't do a lot of the things that we're doing. What I want to do is give you some tools, give you some insights, give you some features that will allow you to pull new data into Tableau and explore it in new and interesting ways. It does include audacious claims. There are unreleased features that I will show you. I will point them out. If you have access to Tableau 10.2 beta, which will be shortly released. Some of you are in an alpha program, so you might see some of the things that you're familiar with. But in 10.2 beta, which everyone can get, you'll be able to do some of these, all the features that I'll show here. So what on earth do you think this sign means? Any guesses? Don't feed the squirrels. What's that? Don't point fingers. All right. Maybe it's squirrels are really, really good at rendering first aid. I have no idea. Actually, this sign was posted at the Grand Canyon in 2014 to warn visitors about a rabies outbreak at Phantom Ranch at the bottom. It actually had to do with foxes. I have no idea how squirrels got in the mix. But what it did do for me after seeing the sign is it kind of emphasized my latent fear, if you will, of squirrels. And so on a recent trip to the Grand Canyon, North Rim, what I wanted to do was find these rabid squirrels. I need to avoid them at all costs, okay? So the way I do that is I'm expecting to find these squirrels using whatever means I possibly can. So I could go to the National Park Service, right, and try to download data about squirrels. Well, guess what? The National Park Service, they don't have that data. So I took to social media, and I said, all right, maybe Twitter. Twitter's great. Lots and lots of content. It's not necessarily good content, okay? Facebook, things are much better curated. Yes, I could probably get pictures of squirrels, real squirrels. And I probably could get really good data. The problem is my social network is really, really small. I'm old, okay? I don't have a lot of friends. I don't have a lot of people in my network. So Facebook was out. But Flickr actually turned out to be pretty good. It's a very small set of data. However, every single picture of a squirrel is geotagged, so I know exactly where that picture was taken. And on top of it, they're pictures. So I can verify that the thing that's actually being photographed is a squirrel, right? It's not my friend whose nickname is Squirrel. So what I intended to do was basically find all these squirrels, collect them into these bins, and display them as a viz. So I did that via this URL. So I'm not going to go through all the process of downloading that URL, but in the end, what we're going to end up with is a viz that looks like this. It looks like hex bins, right? There's actually another talk about hex bins. Dr. Sarah Battersby is going to give that talk. It's a fantastic talk because it'll talk about projections and binning and what kinds of considerations you have. But this right here is the end game for what we're going to do. So I hit that URL for Flickr, and this is the nonsense I get, right? It's just a jumble of XML. But if I look at that XML, I can quickly see, you know what? There are very clearly some things, and I'm sorry for those who have like the red-green deficiency. I probably should have used a different color. But there are those principal elements for each one of those photos that I'm interested in. Now, how do I get this into Tableau? I cheat. I either use a tool like Alteryx, right? In this case, what I ended up doing was a regex expression, right? So I basically cut and paste a bunch of regex expressions, and I filter all this data out, and I end up with, in the end, something like that. Okay? So all it is a series of pipe delimited rows that indicate the photo ID, the name of the photo, and where the photo was taken. So what can I possibly do with this? By the way, anyone know who that cartoon character is? Please? Oh, thank you. Okay. I'm not that old. Good. That's good. So how do I get this into Tableau, and how do I run a lot of those analytic operations using this data? So I've obtained this data from Flickr, geotagged images. How do I get it into Tableau, and how can I build those bins and run point-in-polygon types of analysis? That could be squirrels for me. It might be car locations or point densities or any kind of single point location for you. I'm going to use Spatial Light. It's an open source tool. It's built on SQLite, and it is nothing more than a standalone file-based database with a whole bunch of spatial functions. Okay? How many in here PostGIS know what I'm talking about? Okay, same kind of function set. This is functions like st-contains, st-intersects, add geometry column, st-shift-longitude, st-collect. These are all spatial functions. In addition to those spatial functions, it also includes what are called dot macros, and it's specific to SQLite, Spatial Light in this case, that allow us to do some kinds of interesting things on spatial content. LMGeo will explode contents of multi-polygons into single polygons into individual rows. Dump shape will actually write spatial content to the file system. Load shape takes shape files and loads them into a database. That's all this stuff is. And how do I do it? Well, the easy thing is Spatial Light. It's a downloadable tool. I install it. There are install instructions for both Mac and Windows, Linux as well. And it's as simple as starting it by typing Spatial Light. The only thing that I'm going to point out when you use Spatial Light, if you intend to read or write from the file system, make absolutely certain that you hit this set Spatial Light security equals relaxed. And why on earth would I do that? The reality is Spatial Light interacts with the file system, so therefore it could be interpreted as doing some harmful things to your machine. In this case, all we're telling Spatial Light is you have access to the file system so you can read and write shapefiles. So if you want to use load shape, dump shape, you have to set that environment variable. So if I'm in Mac or Windows, those are the two commands I would have. The next logical thing for me to do is to create a tray of squirrels and put a squirrel in this tray. Tray meaning a bunch of squirrels, like a murder of crows or an unkindness of ravens, right? A tray of squirrels. So in this tray, which is a Spatial Light database, I need to create a table. And in that table, I'm going to create an ID, a title, a latitude, and longitude that match exactly the same structure I had with the prior import table that you just saw. So let's do that. So in here, all I've done is I've started up Spatial Light with that first command, and all I want to do is just create a table inside of Spatial Light. And it's actually very simple because I have a cheat sheet here, because no one wants to watch me type. And that's it. That's all it took. Just created a table. Got some squirrel table, but nothing's in it. The problem is, once I have this table, I need to load data in it. So loading the data, fairly simple. .import. It's a macro that takes CSV content and loads it directly into the table. Let's do that. That's actually fairly easy. All right? And just like that, I now have records sitting in this squirrel's table. To prove that I do, there they are. Awesome. So you look at this and you'd say, you're not doing anything special, Ian. I can do all this stuff in Tableau. You're right, you can. That lat long, I can map every single one of those squirrels. I could even use hex bins, the hex bin calc or function, and create hex bins of this data. But I want to do something special because I don't necessarily want just hex bins. I want different types of binning. But I'm going to use that lat long to create a spatial geometry in this table. It's a spatial type. It's just like an integer or a string or a floating point precision number, a latitude, longitude, right? I want to create a spatial type. So the way I do that is adding a geometry column. So you could, if you know SQL really, really well, you could say, oh, alter table, add column, blah, 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 geometry. Don't do that. Don't do it. At least with spatial light. And the reason why is because spatial light requires a whole set of indexes and support tables and views that actually manage how that spatial data is stored. And so when you want to add a geometry column, be it a point or a polygon or a line or whatever, you have to make sure you use this add geometry column function. And that's all it's designed to do, is just add that new spatial content. Once I add that spatial field, it's going to have nothing in it. So I need to populate that field with actual data. And I will do that with this make point function. So all I'm doing is I'm saying, okay, you've got this new column called geom. And in that geom column, I'm going to update it, creating a point using the longitude and latitude of every single row in the table. So let's do it. It's fairly easy, especially when you can just cut and paste. And so now I have actually created a new column, and I've added squirrels, a point for every squirrel location. Great. So this is great. I've got a bunch of dots in your mind. I've got a bunch of dots that represent every single photograph on the north rim of where these squirrels are. Okay. I need to put these squirrels in a cage. That's the place I want them to be. I'm afraid of them. Recall. But I want 3 different types of cages. I want hexagonal cages. I want triangular cages. I want grid or square-based cages. And for every single one of those cages, I want to count how many squirrels are inside of each one of those cages. And I'm going to do all that work inside of SQLite, and we will export the results and pull them into Tableau. Okay? So this is fairly simple. Basically, we do the same thing we did with the squirrels. We create a grid table, and in that grid table, we create 3 different types of grids. A grid for hexagonal grids, a grid for triangular grids, and a grid for square grids. Okay? That's all it is. And all we're really doing is we're saying, hey, just fill this thing with some dimension of a grid. And that dimension is basically right here. It's that 0.0025, 0.0025, 0.005. That's just the length of the square or the triangle or the hex. And those are measured in degrees. And the reason why it's measured in degrees is because of this geometry 4326. Anyone know what 4326 is? WGS 84 lat long datum, right? It's a spheroid datum. It's lat long. Just think of that. We're storing lat long data in this table. Great. Let's do this. So in here, we'll create the grid. And we're, again, just in SQLite. We create this table called grid, and we add a geometry column. And I should ask, can you guys actually see this in the back? Sort of? Good. They are, yes. And the presentation is recorded, so you'll be able to see and hear my voice again, over and over and over. And so now we've added a geometry column to the grid table. So there's just a type column, and we said, oh, we're going to store geometry in this grid as well. Now we need to put something in that grid. And we'll do that like we did before. We'll create 3 different types of grids. So we've just inserted into that grid table 3 new rows. One is a hex, the other is a triangle, and the other is a square. 3 rows. Why would I say only 3 rows? Hex, triangle, square. And I would think, no, I want this grid that covers all the squirrels that were coming in. Well, it did it. And I'll prove it. Basically, I said, give me the type, name, and then the type of the geometry in every single one of those rows. And it basically said, oh, you have a hex, which is a multi-polygon. You have a triangle, which is a multi-polygon. You have a square, which is a multi-polygon. Well, that does me absolutely zero good. And the reason why is because I need an individual cell for each one of those little cages. I want to count how many squirrels are in each cage. If it's all one cage, one big multi-polygon cage, think beehive, right? I can't discern one cage from the other. So I need to explode these things into all their discrete elements. One row for every single hex grid or triangular grid or square grid. Okay, let's do that. And that's what we're doing here. So we're going to explode these grids into their little constituent elements. We're taking a multi-polygon, and for every element in that multi-polygon, we're going to create a new polygon record. Then, for every single one of those grid types, we're going to count how many of those squirrels are in each cell. And we're going to create this new table called danger, right? So we create a table called danger. We're doing the same thing we've done before, twice before. First time we said add a geometry column to the squirrels table. Then we said add a geometry column to the grid table. Now we're adding a geometry column to the danger table. That's all we're doing. And from that, insert into this danger table the ID, the type, the count of squirrels, where, blah, 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 left ladder join, on ST intersects ggeom and sgeom. Well, guess what? Those are two things. And I understand this is a lot of SQL. I said there would be lots of SQL. But basically, that ST intersects is all it's doing is it's saying for every one of those little squirrel dots, tell me what grid they fall into. That's the join. You might be familiar inside of Tableau. You say, hey, column A equals column B, right? State equals state. ID equals ID. This is another way to qualify a join. It's ST intersection. We're saying the location of the squirrel is how we join it with the cell it falls in. Makes sense? Sort of? Sort of? You'll get to see this presentation again. And then finally, the last line here is dump shape. And I talked about this at the beginning, where I said, okay, you have a table of data, and I want to write a shapefile. And you'll see why a shapefile is important in a moment. Okay, so let's do all these steps, and then we're going to kick over to Tableau, and we'll actually see this. So the first part, which is explode every single one of those elements into discrete elements. And the only thing I'll do here is this. Now you see for every single one of those records, for an input polygon that was a multi-polygon, 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 well now for every single square there's a single polygon. We'll actually see it. And then finally, we talked about this last part. We're creating the danger table, adding the geometry column, and all these other related SQL to finally get us to a shapefile at the end. So let's do that last part. And voila. So now we have this new shapefile that was placed at users I Ericsson T16 demo 1 danger. All right. That's great, Ian. You've given me a shapefile. And up until this point, you could do nothing with a shapefile. You might be able to bring it in a Mapbox, right? You might use QGIS or Alteryx to do the point encoding to bring polygons into Tableau, right? You would have done all those things, and you would say, your life is painful, Ian, make it better. We'll make it better. So that leads us to here. Anyone know this product? I had to try. Okay. So, ooh. Let's do this. not cover the bottom. In Tableau 10.2 Beta 1, you will now see a new option, spatial file. And of all the things that you can now use, shape files, KML files, map info tables, and oh, I didn't add one, GeoJSON as well. So now in 10.2 Beta 1, you guys will have access to all these spatial file formats. Please. Yeah? Yeah, exactly. All right, so let's take this danger file and let's pull it in. And it's fairly simple, right? We exported this directly from Spatial Light. It has an ID, has a type, great. Has a squirrel count, wonderful. Let's just actually play with it on a sheet. And so in here, the only thing that's actually kind of interesting is this new geometry measure, right? This is the thing that is the polygon or the point. Works just like everything else. Let's just double click it. Great, awesome. Now it looks really ugly, right? Because we collapsed everything into one table. We said all the triangles, all the squares, all the hexes, they're all in the same thing. Well, let's do this. Let's take the type and create a quick filter. Great, but I don't actually want that. I want, let's just do a drop down. Great, so now I can see triangles, I can see hexes, I can see squares. Awesome. I already mentioned that squirrel count, is the number of squirrels in each one of those cells. All right, let's just drag that on color. Let's see where they are. Boom, 32. Huh, I wonder what's going on there. Actually, Tableau is an aggregation engine. You may not know this. It sums a lot of things together. And the thing it's summing here is every one of those cells. So just like we told that Spatial Light table, hey, disaggregate everything, put everything into an individual polygon. We in Tableau said, nah, forget that, put them all back together. So in order to prevent that from happening, all I have to do is drag ID. We'll just drag it down here onto detail, and boom. So now I know exactly where those little squirrels are, especially the rabid ones. Let's throw in a couple of streets and highways here. Do I have internet? I do. It's a little slow. That's okay. But now I can quickly switch between hex or triangle or grid. And all of this stuff was powered by running a upfront, yes, it was upfront, SQL selection that computed counts of squirrels inside these grids. Yes? No? Moving on. All right. So, let's go to the next one. You can sync. Really, you can. Come on. Yes. All right. That would have been painful. Okay. I have found my spot in the national park, but I've moved on to Yosemite National Park. And I found a great campsite. It's awesome. It's away from the roads, it's away from noise, it's 2 a.m. I need to find the nearest toilet. And this is called the nearest neighbor problem, right? It's actually a very classic problem in spatial analysis. What I want to be able to do is find all the building locations inside of Yosemite National Park, filter out places where I can camp and places where I can relieve nature's urge, right? And put them on a map and then compute, give me the nearest n neighbors to my campsite. So give me the 3 closest toilets, in case one is out of order, one's occupied, whatever the case may be. So what I do need to do is first find this data. And this data is actually found at the National Park Service. They're so kind as to provide a lot of this data. However, CartoDB actually has this building data as GeoJSON. Now, this was done before GeoJSON, this presentation was done before GeoJSON support went in the beta, and therefore, we have other ways of doing this. We have other ways of getting data into Tableau. And this kind of will lay out how we're going to do this. This is, we're going to touch the boundary here of what's reasonable. So we're going to use PostGIS or Postgres, and PostGIS is an extension that lies inside of Postgres, and it allows you to do spatial calculations and store spatial data in Postgres. So we're going to use Postgres as our connection. We're going to write one heck of a custom query. We'll talk about this in just a moment. We're going to set the maximum number. This is the n part of nearest n neighbors, which is right down here, that one little tiny blue dot. We're going to set up a parameter to control it, and then we're just going to put it on a map. So, hold that all in your mind. Let's do this. So PostGIS, as I mentioned, it's an extension into Postgres. It allows you to contain spatial, or manage, contain, and operate functions on top of spatial features inside of Postgres. It adds spatial functions like st-intersects, not add geometry, that's specific to SQLite. Intersects contains, and a whole bunch of geoprocessing functions. You can download it. It runs on Windows. It runs on Mac. You can, if you have a Tableau server, great. Put it on some Tableau server someplace. It's organizational wide. So, first part of this is setting up, creating a new database, and then making sure that you install the PostGIS extension. So when you install it, it gets installed into the database, and then you need to activate it. We'll show that in just a second. The other component, and I mentioned that this was written before GeoJSON support went into Tableau for 10.2, beta 1, very clear. How do I get other spatial data into formats that Tableau can recognize? We recognize shapefiles, we recognize map info tables, MIF-MID files, KML, now GeoJSON. But if you have some other strange formats, there's a library called GDAL, Geographic Data Abstraction Library, I believe, that provides a number of command line utilities and functions that allow you to manage spatial data and put it in formats that Tableau can understand, right? You may get some kind of data. Please don't get SDTS, but you might get SDTS. GDAL will translate that for you. There are really painful formats out there. Also, same kind of thing. It's a very easy setup and install. If you're using Mac, use Brew. You can install it very quickly. If it's Windows, there's an OSG4W for Windows that allows you to have access to all these tools at the command line. Fairly simple. So, you're going to create a database, and we're going to put a bunch of stuff in it, and then we're going to visualize this stuff. So, first part, create database, TC. And I'm actually not going to type all these things. We'll show you the queries. We'll show you the tables behind the scenes. So you don't need to see me type. The second part is create an extension. So what we have done here is, okay, you've created a database, which is the container for everything you need. You need to spatialize that container, that database. And you do that by typing create extension PostGIS. And all that will do is signals to Postgres, oh, you intend to use all these spatial functions. You want to store spatial data in this database. That's all it's saying. So once we type all of those, we need to now get data from this outside source. In this case, it was a CartoDB query that contained building data. And we need to get that data somehow into PostGIS. That is what the data looks like. Now, because it's GeoJSON, I could have just imported it. Nah, let's do it the hard way. Looking at this, you'd go, what does this mean? This is OGR to OGR. It's a free tool out of that GDAL library that I just mentioned. OGR to OGR allows you to manage some spatial formats and transform them to other spatial formats. You can do all kinds of fun things. You can run select queries inside this tool. You can transform the data from one projection system to another. But that looks kind of complex, so let's just step through it. The -F means I intend to push all of this data to an output format, F, of PostGIS. So all the data that's going to go through this tool is going out to PostGIS or Postgres. The second part of this is saying, okay, that -T under SRS EPSG 4326. We're saying transform this data, which might be in any spatial format and projection system. You don't know. It might be state plane, it might be UTM, it might be anything. But we want to take this data and transform it as it goes through this pipe into WGS84 lat long data, lat long. Then there are a bunch of creation options. So when we create this table inside of PostGIS, we're saying, hey, it's going to be a geography type. There are two basic types in databases when it comes to spatial: geography and geometry. Why the difference? Any guesses? Sphere, right. Earth, round. Geometry, flat, right? So when you talk about geometries, we're projecting something to a planar system. We're saying, hey, all this data is flat. We've defined some coordinate system for it. It might be in meters, might be in feet, might be in inches, might be in centimeters, don't know. But in this case, we're saying, no, PostGIS, store this data in geographic coordinates, which means put it on a sphere. And when you do this, there's a limited number of functions that you can use inside of PostGIS to manage that data, but once you do, your calculations are guaranteed to be correct. The other part is layer creation, geometry name. So the new column name that we're creating is geog right here. Okay? And then finally, the data is going to be UTF-8, which means full character set, right? And NLN means put it in a table called Yos Buildings. Y-O-S-E, Yosemite _ buildings. Great. Easy. Then I tell it, how do I connect to PostGIS? Oh, I give it a DB name. I tell me what host. Yes, my password is Postgres. And then I do something kind of novel. I say, oh, of all this data that's coming in from this GeoJSON format, only give me the name, the place ID, the type, the unit code, and this hard-coded value of 0. So basically, I'm creating this table from nothing. And I only want to see the YOS data, Y-O-S-E, because that building data contains all the buildings for every national park in the national park system. I am only concerned with Yosemite National Park. And this, of course, is where did this data come from? Great. Awesome. Once I've got all that stuff in there, the interesting thing about this set is that in the prior example, we started with latitude, longitude. And we had to create a geometry. Remember, make point? In this case, we have a geometry, but we don't have a latitude, longitude. And in case you guys have never used paths or like paths or hate paths, I hate paths. They're not easy, but in order to use a path, I need a lat long. I need an origin and a destination. So how do I get that? Well, I can't tell Tableau, oh, just use this geometry thing. I don't have a way to say, oh, just use the centroid or the center or the corner of that thing. Not yet. So I have to tell PostGIS, create two new columns called latitude and longitude, and from those latitude and longitude columns, from the geometry, populate that latitude and longitude column with the center of that geometry. So this is a building outline. I'm saying take the center, and that's the thing that I'm going to call latitude and longitude, X and Y for that table. I'll show you an example in just a moment. This whole nonsense down here is really saying, remember that 0 that I set for camping is 0? Basically, I said everything in here, you can't camp. Now I'm running a query that says, oh, if the name is similar to cabin, apartment, bunkhouse, lodge, tent, hut, cottage, but not shed, who wants to sleep in a shed? NPS, ranger, SAR site, patrol, employee, office, definitely don't want to sleep in a toilet or a restroom. But basically, this is a filtering query. And basically, all I'm doing is setting that camping flag for one field to 1 when it matches this criteria. Great. Seen that, seen that, seen that. Awesome. This is what you get. Bunch of hexadecimal display. If you were to query this inside of PostGIS, this is what you get. This is the geometry. This is the building outline. You're not meant to actually understand that. That's why we have a GIS. That's why we have Tableau. And then we have names, places, building type, camping 1 or 0. So based upon the name here, we're saying, hey, we can't camp in a building, but we might be able to camp in Murchison House. Maybe. Maybe not. Don't ask the ranger, just do it. So now I've got buildings, just generic buildings. I need to classify the buildings into 2 different tables: camping locations and toilet locations. Simple, easy. So I create one called Yoast Camping, one called Yoast Toilets, just like the other 2. The slide says, I'm sorry, and I am, because you're not meant to read this. Yes, it's ugly. We're going to step through it. This is the query that does nearest neighbor. So inside of Tableau, we'll set a new custom SQL connection, and we'll actually parameterize it with this query. But in order to understand this query, let's step through it so it makes a lot more sense than just this. So this is the first section that we're going to look at. Again, you're not meant to know all the SQL, but we'll get there. When I zoom in, this is what we're talking about. And if every one of those little components of that SQL statement we can talk about atomically, because I could run this query by itself, and you wouldn't have to know anything about it. The key thing that you should understand about this particular query is this left lateral join on true. Basically, all this means it's a for each statement. How many devs? How many people who actually write a little bit of code? Anybody? Okay, great. So it's a for each statement. Okay? This is saying for each record in this top section, do something with this bottom section. That's all it's saying. And the cool thing about a left lateral join in PostGIS is that you can use a C alias, the alias for the other table, in queries in the bottom section. So I can say for each up here, I can reference C down here. Way cool. So I can say, hey, use the geometry from up there and compute something down here. That's all this left lateral join does. So the first part is actually fairly simple. We're just saying give me the campsite ID, the campsite name, the latitude, longitude, and the geography, the shape from that camping table. That's all we're saying. So that's our for. Right? For every one of those records that come back, we're going to do something with it in this bottom section. And the bottom section actually isn't that bad either. We're saying, give me the campsite, name, latitude, longitude, geography from the toilet where, don't worry so much about this, we're saying the toilet ID and the campsite ID can't be the same. Well, we've already clarified that in a prior query, but this is just kind of like a safety check. And stExpand. What is all this stExpand, stDistance stuff? stExpand basically says you've got a shape, whatever that shape is. It might be a building footprint, it might be a point location, it might be a line. And we're saying take the bounding box of that shape, and in this case, on a sphere. Way cool. And expand it by 0.009 degrees. Now, what's 0.009? It's about 1,000 meters at this latitude. Okay? I arbitrarily chose that. You can go up, you can go down. It affects the optimization and the speed of the query. That's all it does. This double ampersand is really cool because basically what we're saying is, okay, take this box, this virtual box that you've drawn around a building. You have a building, we have a box. Take that box and tell me if that box intersects. This is a shortcut for a bounding box intersection. So inside of PostGIS, it knows that double ampersand means bounding box intersection. It's way cool. The toilet geometry. So put a box around all the campsites. Tell me if they intersect or touch any toilet. It's great. So now I have this smaller subset. So I have all these toilets. I have one campsite. I have a box. Okay, there's maybe 50 within 1,000 meters. Great. order by SD distance. So of those 50, order them from closest to farthest. But only give me 5, or 3, or 15, or whatever. This is the n part of nearest n. Okay? Great. Awesome. So we've got all this working. I can then take the results of all this, all these queries, the C part and the T part, and put them all up into one simple query at the end. And it says, oh, give me this path ID. So I'm creating this new path ID, which is really the aggregate of the camping ID and the toilet ID with a dash between them. That's all I'm doing. And so I say, okay, great. Give me the path ID. Give me the campsite ID, the camp ID, the toilet ID. Great. And the distance between them. Awesome. What I end up with is something that looks like that. Now, this is the nearest 5. Some of them don't have any. I do not want to camp there. It is a long walk. Some of them only have 3. Some of them have 2, and so on. So for that table, so imagine you have this path ID, the campsite ID, the toilet ID, and a distance. Now I need to move, this is the first part, I need to move down to the second part here. And the only reason this query looks the way it does is to support paths inside of Tableau. Paths are nasty because I have to have them on separate rows, right? I share a path ID, then I have some kind of sequence, and then I have potentially some order of magnitude or distance or whatever. In this case, it's going to be distance. So just like we had this first section, I'm doing a for each. So for every record that you just got in that prior query, do something with it down here. Well, all I'm doing here is basically putting those 2 rows that constitute the path together. And so let's step into that one. This is it, blown up. Again, the left lateral join, the for each part. This is the magic. We're basically saying the first row is coming from the camping table. The second row is coming from the toilet table. Origin, destination. Great. And I just want the name of the path from the distance table that you saw before for each distance record. Give me the distance path ID, the name of that thing, whether it be the campground or the toilet, the latitude, longitude, and 0 at the end as distance. So the first one is always 0. Okay. The bottom one is the distance as reported in that first table, that first query that we ran. So we had, 753 had 254, and 753 had 279. That D is this bottom section. So we for each all of that together, and we end up with something, when you put that whole query together, that looks like that. Guess what? Path ready, right? So let's take this query and let's drop it inside of Tableau. And yes, I'm going to cheat again. You do not want to watch me type that thing. So there's our query. And we'll go here to Tableau. And great. I think I typed that correctly. It will tell me if I didn't. Yes, it will. So let's take this new custom query. And guess what? It's that paste. Because you have just worked 4 hours on this query. And we'll report it as such on your time card. But now all I need to do is parameterize it, right? Because I want to control how many options I have from every campsite. Okay, let's do it. Let's actually find the parameter first. And I can't make it bigger, darn. So there's our 5. We talked about that limit. That was the key. That's the piece that says the nearest n part. Great, let's highlight it. Let's insert a parameter. Great, let's call it nearest n. It's an integer. Sure, let's make it start at 1. Let's look at a range. We should probably limit this so that my poor little PostGIS server doesn't really complain. And so now we have this parameter nearest n just injected into the query. Great. Run it. All right. And so now I'm sitting here thinking, okay, how do I get paths? I told you they were difficult. So I'm going to pull these back up here. We'll drop these here. Wonderful. Come on, maps. Come on, there we go. Let's make it dark. Because after all, this is 2 a.m., right? Let's add a couple of streets. I don't need counties. And let's make a path. And let's do a path ID down here on detail. And the moment I do this, I should, in theory, have lines. And I do. And they're not really the prettiest lines, but I can see that if I'm here at this little campsite, I have, actually, here at this campsite, I have one option. What I want to do is let's color and code the distance. And you know what, let's size the distance as well. So the farther I have to walk, and let's reverse it. Great. We'll add some color. Wonderful. And we talked about this nearest n. Let's create a parameter for it. Great. So now we can go from 1 to 3 to 5. And all the while, all I'm doing is running those selection statements behind the scenes that's saying, okay, here's your path IDs, building, campground, nearest n. That's all I'm doing. Cool? All right. I have a few short minutes to show you one last thing. Let's go here. Oh, don't start. Yes, okay. We're going to go as far away from national parks as we possibly can. It's actually a pretty sad and sobering thing. But one of the things that I showed in the very part of this was you had this concept of points and point density, and we put them inside these containers, these cages, right? Put squirrels in cages where they belong. And that's fine, except sometimes those cages are artificial. The boundaries are not realistic, right? Sometimes there's a continuous spread. And what I really want to do is examine how the density of points transitions over distance. And we do that using traditional means like inside of GIS packages, using heat maps and contouring, right? So we can display now with spatial files, we can display a lot of those contours inside of Tableau. So the way this is going to work, I'm going to pull in all of these crime statistics from the city of Chicago. We're going to filter on just homicides, because I don't necessarily care so much about assault, but if I wanted to focus on those individual assaults or larcenies or whatever, I mean, I have that data. We're then going to do a bunch of interesting things like create a heat map. We're going to contour that heat map. We're going to generate some polygons from that heat map. And then we're going to sort the shapefile? What? Let's just do it. And that is what we'll end up with. So this is the data from the Chicago city. And basically, it's crime statistic data that goes all the way back to 2001, or no, 2006, I think. It's either 2001 or 2006. I'll have to look it up. Nevertheless, it's lots of data. It's actually 1.4 gigs worth of data. And the unfortunate thing is, and you've seen this before, but we'll go through it fairly quickly. This is nothing more than, it's delivered to me as a shapefile, but I only want A, homicides, right? And B, it doesn't actually have a geometry. It just has a latitude and longitude, which is, in theory, fine for Tableau, but not for QGIS. And QGIS is the package that we'll use to create that heat map. So QGIS needs a geometry, so that we'll step through this fairly quickly. shapefile. That's the destination format. We've seen this before. It's saying the source is latitude, longitude, transformed to this other strange number, 32616. That's UTM zone 16. So all the measurements will be flat on a plane in meters. Meters, it's important. Meters, not degrees, not some strange measurement. Meters. All the data will be coming in UTF-8. Here's an ugly, ugly, ugly select statement. It's basically saying, take the fields out of that shapefile and do something with them. I only want ID, well, ICUR, Uniform Crime Reporting codes. Primary type, beat, district, ward. Then I break out the month and year. So if you wanted to do multi-year or multi-month analysis, you could do that. And a longitude, latitude from the Chicago crimes where the primary type is just homicide. Great. All this other nonsense here, this and cast, longitude, blah, 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 the data's bad. Some of the points are showing up in Africa, some points are down in the Philippines. I can guarantee you Chicago's probably not looking at crimes in the Philippines. So I had to constrain the domain for the lat and long. That's all that main section does. And then finally, write it out to a shapefile, chicagohomicides.shape. And the source file, which is odd, is this VRT thing. The heck is a VRT? I downloaded a CSV file. This is what a VRT is. Basically, OGR, the GDAL tools, allow you to say, oh, there's a wrapper around CSV. And when you encounter a CSV, you can create a point using columns. So that's all a VRT does. It basically reads a CSV and says, oh, you want me to build a point based on long and lat? Great, awesome, I can do that. And so when you run all this, you end up with a shapefile. So let's show you the shapefile. And QGIS is the other package that we're using. You can download this free. It's a free tool. And let's pull in this demo data so we can see it. Awesome, there they are. And in this case, we'll actually create a heat map from it. Oh, let's create a heat map if it will let me do it. Yep, sure, why not? Awesome, that's what it looks like. I need to contour this. Okay, well, there's a tool for that. There we go, contour. And we'll call this oops. We'll change the field in which it goes to. Hopefully that's going to work. Great. Oops. Now we have contours on top of this thing. So we can actually turn off points and lines. Oops, points. That's what I ended up with. But they're lines. I actually want filled shapes. So that would be back up here at Vector, Geometry Tools, Lines to Polygons. Great. Awesome. And you look at this and you now say, well, that's great. I lost all my lines. This is the sorting. Unfortunately, some packages will try to mess with your mind. And you will say, where did all my data go? It's actually all there. Unfortunately, the way it draws these things happens to be from bottom up, and the bottom happens to be the smallest thing. So rather than stack it like a layer cake, no, I put all the biggest things on top of the small things. Well, that has an effect inside of Tableau. So I need to invert the sort. And I invert the sort by actually running this query at the very end, which I will just highlight and not actually run. But basically all it does is takes those contours, resorts them from biggest to smallest, so that when Tableau draws them, it's big, 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 middle, 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 small, small, small. In the end, what you get inside of Tableau is, we won't do that one, let's just do the demo one. And again, Tableau 10.2, beta 1. Ta-da! And let's do the index on color. Great. What happens? Oh, guess what? They're all the same thing. How do I do that? Again, take the ID, drag it to detail. They're now individual elements, and we can make them all pretty. We'll reverse the color. And let's make it even prettier. Change the opacity. No border. Great. Awesome. Ta-da. That's it. One quick thing. We will repeat this. If you have other people in your organization that want to see the same kind of thing, you're like, oh, yeah, that dude was totally awesome. Or, if you're looking to kill time, you can go to this guy's presentation. Either way, it works for me. Those are the 2 repeated sessions. The other related sessions that I want to call out, I talked about Mapbox. The other one is this map projections. Realize why my degrees measurement on hex bins is a really bad idea, but serve the point. And last but not least, please, please, please complete your survey. Help everyone else. Help me get better. Thanks much.